So in today's class, we will be discussing the new topic. It is thermodynamic systems. Thermodynamic systems. In previous video lecture, we discussed the definition of thermodynamics. So these are the topics we discussed. Definition of thermodynamics, TD for thermodynamics. Second point, what we discussed, and macroscopic approach. Third point, microscopic approach, definition of system, and surrounding. So these are the definitions we discussed in this module in the previous video lecture. System, surrounding, and a boundary. So these are simple definitions. Okay. So if you have any doubts in understanding system, and you can comment on, or you can go and watch once again the videos, you'll understand better. So system is nothing but, dear students, assume it is machine, one simple machine, or it may be one device. Okay. So that is system. So there are three types of systems in thermodynamics. First one, open system. It is open system. And second one is closed system. And third one is isolated system. So in thermodynamics, there are three systems. One is open, closed, and isolated system. How they will ask in the exam is define thermodynamic system and classify with examples. Or else what they do is they will give some examples. Okay, 5 to 6 examples they will give. 1, 2, 3, 4, 5, 6 like that. Out of 6 examples, you need to classify or categorize how many open systems are there, how many closed systems, and how many isolated systems. So this is how the university will ask you two questions. What is the question is, define thermodynamic system and classify thermodynamic system. Or else they will give examples and you need to categorize which one is thermodynamic open system, which one is closed system. Okay. First, what we do is we'll discuss the definitions, and as well as we'll discuss the examples also. First, open system. As I told you, system is nothing but one device, one machine. Okay. It may be laptop, it may be mobile, it may be turbine, it may be compressor, any device, wherever you are seeing in surrounding, maybe in the classrooms, maybe in the industry, maybe in the outside. Bus is also a system, engine is also one system. So we have many number of systems surrounding us, and we need to classify which one is open, which one is closed, which one is isolated. First definition of open system is, a system, open system is a thermodynamic system, a device or a machine. For example, I will draw one simple square box. Assume this is a machine. This is one system. If this system is taking some working fluid, mass in, and this system is rejecting some mass out. Okay. At the same time, this system is absorbing one kind of energy, one form of energy in. And this system is converting absorbed energy into some other form of energy, that is energy to another form. One form of energy is converted into another form. So any system where there is an exchange of mass and as well as energy conversion between system and surrounding, that system will call it as open system. Okay. And dear students, system is nothing but a device. So this is a boundary. The outside layer of the system is called boundary. Anything outside the boundary is called as surrounding. This is surrounding. So this is system. So this system here some mass is going inside. The mass may be water, air, gas, petrol, diesel, whatever may be, some working fluid, some mass of fluid entering inside the system, and it is going some process inside the system, and some mass is going outside. Mass is nothing but, keep in mind, working fluid, some kind of fluid interaction. At the same time, this system, this device, this machine is converting one form of energy into another form. So that system, that device, that machine, we'll call it as open system. And dear students, now you tell me examples. You gave me name of the machine or name of the engine where there is a interaction of mass is going inside, mass is coming outside, and as well as it is absorbing one form of energy. It may be kinetic energy going inside, potential energy, mechanical energy, chemical energy, whatever may be, where you are seeing kind of energy interactions. ಹೇಳಿ ನೋಡೋಣ, ಎಕ್ಸಾಂಪಲ್ಸ್ ಹೇಳಿ ನೋಡೋಣ ಯಾವುದಾದ್ರೂ.
It's a car engine.
Car engine, very good. Car engine is a best example of open system. So on what basis you said car engine is a open system? Could you elaborate your answer?
Sir, the intake of mass is like fuel.
Yes, fuel is going inside, that is petrol.
And the
Yes,
petrol. And
yes,
the out mass is mechanical energy.
yes. Petrol is
Smoke.
going inside, which is a working fluid, it is coming outside. Working fluid.
Working fluid
Petrol,
is smoke, sir.
yes, smoke, that is gases. And dear
Yeah.
students, always don't think that petrol should go inside and petrol should come outside. It is not like that. Some kind of mass interaction. The water is going inside, vapor may be coming outside. Petrol is going inside, gases are coming outside. Gases are going inside, some water is coming outside. Maybe, okay. So there must be any mass interaction. And as well as car engine is producing some mechanical energy. So energy output, energy in. Now you can ask a question that which energy is transferred to car engine? Chemical energy, because we are supplying fuel, no? Fuel or petrol, it has some chemical energy. That chemical energy of the fuel is converted to mechanical energy with the help of car engine. There you can see exchange of mass, that is petrol, diesel, everything, and gases are coming out through silencer. So it is a best example of open system. Okay, dear students, now one important question I will tell you. I will ask you. Okay, now based on that, you tell me whether it is open system or closed system. How many strokes will be there in the engine? 2
Four
strokes,
stroke, sir.
4 strokes, 4 strokes. So dear students, now I will draw first stroke. This is cylinder, this is piston, this is inlet valve, this is outlet valve. In which stroke petrol enters inside the cylinder? Through inlet valve?
Inlet valve.
Yeah, that is suction stroke. In the suction
Yes, sir.
stroke, the petrol and air enters inside the cylinder. So means, what does it mean? Inlet valve open, so petrol and air comes inside.
Opens.
Correct. The next one is compression stroke. So during compression stroke, will the petrol will go outside or the gases will go outside? No, no.
Sir, both are compressed.
Yeah, in the during compression stroke, both inlet valve and exhaust valve will be closed. Both inlet valve and exhaust valve will be closed.
Yeah.
So there is no exchange of mass. Gases is not going outside. Petrol is not coming inside. Correct. There is no exchange of mass. But mechanical energy will be there because we are compressing the fluids.
Yes, sir.
Reciprocating motion will be there. Okay. Third stroke, expansion. During expansion stroke, again, there is no movement of inlet valve and exhaust valve. That is exhaust valve or open outlet valve. Both will be same. So there will not be opening and closing of inlet wall and outlet wall. So in the expansion stroke, there is no mass exchange. There is no mass exchange. In the compression stroke, there is no mass exchange. But in the exhaust stroke, the inlet valve will be closed and exhaust valve will open. So gases will go outside. So mass is going outside. There is an exchange of mass. So exhaust stroke, mass exchange. Section stroke, mass exchange. You have to be careful, my dear students. Such type of questions will be asked during compression stroke and expansion stroke, whether the car engine is a open system or not. In such case, you have to say yes, no, compression stroke and expansion stroke, there is no exchange of mass, so it is not a open system. Understood? It is not a open system, it will be closed system. So what is the definition of closed system? I will explain now. Okay, later I will give some examples. You have to tell me whether it is open, closed or isolated. First, let me finish the definitions. Okay, so just an example, you have given car engine, it is a good example. So what we do, you'll understand the definition of closed and isolated, and I will give some examples. Based on that, sorry, next. So based on that, you have to tell which one is open, which one is closed, which one is isolated. So I will define now closed system. Closed system, it is a thermodynamic system first, or it is a machine. It is one device. So machine, I will draw one simple sketch. This is machine or system. Anything outside the system is called surrounding. This is surrounding. For example, your home, where you are sitting now, your home is a system. The neighboring home is a surrounding. For example, you are sitting in your bedroom. So bedroom is a system and the kitchen room of your home is a surrounding. So anything outside the system is called surrounding. And one point you need to remember, the layer or the partition, the layer which separates system and surrounding, that is called as boundary. So this is boundary. For example, you take potato. If you are considering potato as a system and surrounding is here, the potato layer is a boundary. There is thin layer will be there on the potato, right? So that is a boundary. If you are considering human body as a system, the skin is a boundary. Okay, that's like example. In the closed system, the main thing is this system or machine or device absorb one kind of energy in and energy out. But there is no exchange of mass. In the open system, there will not be any flow rate of water or flow rate of gas, flow rate of petrol. So mass exchange will not be there. Only energy exchange will be there. This machine is taking some kind of energy, and that system, device, machine, converting this energy into another form. Or same energy is going, kinetic energy is going inside, kinetic energy is coming outside. Energy exchange, energy conversions. Okay. But such type of examples will not be there. Always when your same kinetic energy is there, inlet and outlet, no use of installing such machines. That is closed system. Keep in mind, my dear students, in a closed system, no exchange of mass between system and surrounding, but only there is an exchange of energy. Energy will go inside, energy will come outside. Or you can write in simple word, a closed system is a thermodynamic system in which there is a kind of energy conversions between system and surrounding, but there is no exchange of mass. Next, last one is isolated system. isolated system. What do you mean by isolated system? System, nothing but again, some machine. Keep in mind, it is a machine. Machine may be a turbine, compressor, fan. Isolated system, let me take one simple machine, system, and device. Both are, all three are same. In general, we'll call it a system. In some rare case, we'll call it machine and device. In the isolated system, this machine, this device, or this system does not exchange energy, no exchange of energy, and no exchange of mass. Both mass is not there, mass out will not be there, and as well as energy out will not be there. So any system or any thermodynamic system in which it does not allow or does not exchange, does not convert both energy and mass, that is called as isolated system. Simple. So isolated system is a thermodynamic system in which there is no exchange of mass and energy. You can write in your own words, no issues. Exchange of mass and or energy. So this system is called isolated system. Okay.
Sir, then what is the use of this, sir?
Does not exist. There are some systems, for example, dead body of a human body. Human dead body. Dead body is, it is a machine. Actually, it is a body. It is a device. Correct.
Hmm.
But no exchange of mass. There are some isolated systems are there. There are some systems are there. It is considered isolated,
Okay.
but it is no use. Very good point you have asked. No use of such systems. But in the industry,
Okay, there is no
90%.
use of isolated systems, sir.
No, not that much. And
Oh,
sometimes
okay.
for analysis, we'll assume it as isolated for analysis. But
Okay.
90% of the devices, 90% of the systems in the industry, all are open systems. All are open systems. So remaining some 10-20% are closed systems. Okay, now,
Okay.
dear students, I will give some examples. Based on that, you tell me whether it is a open or closed or isolated system. So to understand open and close, I will summary. I will give some simple table here. In the open system, exchange of mass and as well as exchange of energy, mass exchange and energy exchange, mass and energy. This is open system. But in the closed system, you draw square box like this, and you can say only energy exchange, only energy in, energy out, but no mass interaction. Okay, and in the isolated system, no mass exchange, no energy, no mass going outside the system, no energy. Okay, this is isolated system. I will give examples, my dear students. So you said car engine, it is a petrol engine. Okay. So let me take a engine, petrol engine, or it may be diesel engine, or it may be gasoline engine, whatever may be the LPG gas, whatever. So petrol engine, if you consider all four strokes, then it will become open system. Open system, because petrol is going inside in the engine, and this engine is converting to mechanical work. So both energy is also there, and as well as mass is also there. So it will be open system. But if you are considering only two strokes, that is compression and expansion process, let me write here petrol or any engine. Dear students, do not confuse with the word petrol. It may be any engine. Petrol engine for compression and expansion process. So during compression and expansion, both inlet valve and exhaust valve will be closed. When both valves are closed, it understood that there is no exchange of mass. If the inlet valve is closed, petrol will not come inside the engine. If the exhaust valve is closed, gas will not go outside the engine. So both gas mass is restricted. It is not flowing. It is not going outside. So only you can see energy exchange. So in that case, you can it as closed system. Closed system.
Sir, can you repeat once again, sir?
In the petrol engine or in any engine, compression stroke and expansion stroke. So during these two strokes, during compression and expansion, during this stroke, inlet valve and exhaust valve will be closed. When both valves of an engine like this, inlet valve is also closed, exhaust valve is also closed. When any engine which has inlet valve and exhaust valve was closed, no question of mass enters inside the cylinder and no question of gases are going outside. So we cannot see there is exchange of mass. Mass is nothing but petrol and gas. Petrol is not coming inside the cylinder. Gases are not going outside of the cylinder because valve is closed. So only the piston will move up and down. In the compression stroke, it will move from BDC to TDC. In the expansion stroke, it will move from TDC to BDC. Piston is there, piston is movement is there, energy is there, reciprocating motion is there, but working fluid is not there. No exchange of working fluid. So it is closed system. Because what is closed
Sir,
system?
but in open cycle also, if the compression is there, the two valves are also closed, no, sir?
Yes, yes, but you are considering all four strokes. Combination of all four stroke is a open system. But here I am considering only compression and expansion.
Okay, okay. Okay,
Okay,
sir.
this
Okay.
is a question it has asked in the Tata company for one of our senior.
Okay.
What the question they have asked is, during compression and expansion stroke, whether the petrol engine or engine, it is a open system or closed system. They mentioned that during compression and expansion. In general, it is a open system. In general, if you consider all four strokes, complete cycle if you consider, then it is open system. But
Ah,
they are asking only for compression and
if
expansion. Okay, I've understood.
okay, okay, okay. Yes,
Okay,
sir. Yes, sir.
now I will give an example, my dear students. Thermos flask. Thermos flask, whether it is a open system, closed system, or isolated system. What is flask? Why it is used? Where you will see the flask?
Flask. The flask is the energy storage, sir.
Energy storage. Anybody? Other students? Okay, let me open some screen. I will show you some pictures. Flask, where you will see in the flask? ಎಲ್ಲಿ ನೋಡಿದ್ದೀರಾ ಯೂಶುವಲ್ flask?
Sir, as usual, coffee store ಮಾಡಕ್ಕೆ, tea
Coffee
store ಮಾಡಕ್ಕೆ while
store,
traveling.
yes. Flask. Are you able to see the picture?
No, sir.
Okay, now?
Sir, ಇವಾಗ
Yeah, this is a flask. Correct. Where you have seen this
Yes,
flask? Usually, as you said, it is used for storing some
Coffee.
coffee, some fluid. Okay, correct.
yes, sir.
Okay.
Yes,
So
sir.
in the hospitals, you might have seen some. You may carry some milk to your patients and some etc. So during
Yes, sir.
that particular period of time, have you seen any exchange of mass? Whether tea is coming outside,
No, sir. But in the form of vapor, it will be.
but it is closed. No, tap is closed. I am not
Yes,
said
sir.
flask is open.
Sir, but
But
the surrounding heat where we hold the bottle, sir, it will
Uh,
be heated.
okay, my dear students, if
Where
the heat is going outside, then what is the use of flask? Okay, keep it. Try to understand the phenomenon here. For beginning of for 10 minutes or 15 minutes of time, the temperature of the tea or the working fluid, whatever it is there in the flask, will not decrease. After some period of time, after 1 hour, after 2 hours, after 3 hours, slowly the temperature of the tea goes out. Correct or not? Correct or
Yes,
not?
sir.
So for a
Yes, sir.
period
Yes,
of
sir.
time, for example, this is your coffee shop, this is your hospital. So when you are moving this flask from coffee shop to hospital, whether there is a decrease in temperature of the tea, the temperature of the coffee?
Yes, sir.
No, they will
No,
not
Decrease
sir.
in temperature.
correct or not? So for that period of time, it
Yes,
is
sir.
a isolated system. What is
Okay.
isolated? Isolated means no exchange of mass,
Remaining same.
same. No exchange of mass, no exchange of energy.
And energy.
Correct. So it is isolated system. Okay. Next. And all these examples they will ask in the exam. Okay. Simply I am not telling the examples. Okay. One more time. Now I will coming back to the industry oriented. This is turbine. Turbine. Here I am supplying steam. Listen my words carefully. I am supplying steam. This steam enters the turbine, hits the blade, and it converts to mechanical energy. That is rotary motion. Mechanical energy is coming outside, and excess steam will go outside. Steam out. You can consider steam or gas, anything. Okay. So with respect to this example, it is open or closed or isolated.
Sir, open,
Sir,
sir.
it's a
Open.
closed cycle.
Open
Open,
system.
open. Sorry. Open.
Why it is open system? Because steam is
Because
a
in
working fluid. Mass is going inside and
Hmm.
mass coming out. Correct?
Okay.
Okay. And exchange of energy, mechanical energy is coming out. There is some kind of energy coming outside the turbine. And dear students, always keep in mind, either energy is in or maybe out. There is no condition that both should be there. Innu irbeku, out irbeku antilla. Bari out idru okay. If the energy is going inside, andre, that is only one kind of energy. Yavadaದ್ರು irli. Either energy is going in or energy is coming out. Understood? So you can ask a question, sir, where is the energy input here? And here heat energy is going because I am using the word steam. Heat energy, Q will be there, some temperature will be there, some pressure will be there. Correct or not? So it is a open system. Next, pressure cooker, when the lid is closed, clear ಆಗಿ ಕೇಳಿಸ್ಕೊಳ್ಳಿ. Pressure cooker, the lid means piston is closed. Which type of system it is? Clear ಆಗಿ ಕೇಳಿಸ್ಕೋಬೇಕು.
Closed, sir.
Closed?
isolated.
Okay, let me open one. Can you see the screen?
Yes, sir.
Pressure cooker with lid is closed. If you see the example picture, you'll understand better. Okay, let me open some pictures. Okay. Yeah, here, take this. Whether this lid is open, assume that this lid is closed. Okay, here the lid is closed. So at this condition,
Hmm.
what is type of system?
Sir, isolated.
It is a closed, sir.
Only
Closed,
there will
closed.
be any
There
one.
is only heat exchange, heat
When the
energy.
lid piston is closed, pressure cooker means it is not used for only cooking purpose. Okay, that you need to understand. ಅಯ್ಯೋ ಪ್ರೆಷರ್ ಕುಕ್ಕರ್ ಮೇ ಬಿ ಇನ್ ದ ಕೋಲ್ಡ್ ಅಡಿಗೆನೆ ಮಾಡ್ತಾ ಇಲ್ಲ ಸುಮ್ಮನೆ ಮನೆಯಲ್ಲಿದೆ ಡೆಡ್ ಬಾಡಿ ಇದೆ ಆ ತರ ಇಲ್ಲ ಪ್ರೆಷರ್ ಕುಕ್ಕರ್ ಇಸ್ ಯೂಸ್ಡ್ ಫಾರ್ ಮೇಕಿಂಗ್ ಸಮ್ ರೈಸ್ ಕರೆಕ್ಟ್ ಕುಕಿಂಗ್ ಪರ್ಪಸ್ ಸೊ ವೆನ್ ದ ಲಿಡ್ ಈಸ್ ಕ್ಲೋಸ್ಡ್ assume this is a pressure cooker, this lid is closed. When the lid is closed, no question of steam is going out, correct or not? Whether steam will go out when the lid is closed?
No,
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 but
sir.
energy will go out. Some if the temperature inside
Yes, sir.
the cooker is more, energy will go out. Or if you are heating on the burner, this pressure cooker is on their burner and you are supplying heat energy, no? You are supplying some
Yes, sir.
temperature. So heat is going in or heat may be coming out, depends upon the situation, condition. But there is no exchange of mass. Water will not come outside. So it is a
Mm. Close to site.
closed system. Cycle closed system.
Oh.
Okay. Now I will change the words. Pressure cooker, the lid is open. Pressure
Yes,
cooker,
sir. It is open cycle.
the lid is open. When the lid is nothing but piston. This piston. When the piston
Mm.
is open, obviously some water vapor, some steam will come out.
Mm.
So
Yes,
mass is
sir.
coming out, and as well as energy will also come out. So in that case, it is a open system. Okay. When the lid is open, it is a open system. Okay. Next, one more, my dear student. Last example, seventh one. Assume this is a cup of tea. Tea is there. Okay. A cup of tea placed on a table. This is a table. Here it is tea. Temperature is there. So now you tell me, I am using the word, it is temperature. T is nothing but, obviously, common sense you have to use, it is a hot temperature, hot fluid. So in this case, whether it is a open system or closed system.
Sir,
Sir, it is open.
open.
Open system. Why it is open system?
Because the
The heat
vapors
exchange is also
contain
happening
heat
and the vapor is
exchange.
also.
Vapor will not become outside when it is tea. Heat is there, it is not vapor. Heat is there, that is heat. Whether steam is coming out, if the steam is coming outside, after 10 minutes of time, there should be decrease in the quantity of the tea. ನಿಮ್ಮ ಪ್ರಕಾರ ಮಾಸ್ ಹೋಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಟೀ ಕ್ವಾಂಟಿಟಿ ಏನಾದ್ರು ಕಡಿಮೆ ಆಗುತ್ತಾ? ಓನ್ಲಿ ಫಾರ್ ಇನ್ಸ್ಟೆಂಟ್ ಆಫ್ ಟೈಮ್ ನೋಡಬೇಕು, ನೀವು ಹೋಲ್ ಡೇ ನೋಡಂಗಿಲ್ಲ. ಓನ್ಲಿ ಫಾರ್ ಇನ್ಸ್ಟೆಂಟ್ ಆಫ್ ಟೈಮ್. So it depends on you how you will justify your answers. If the vapor is there, then it is open system. But when the tea is in hot, it is placed on the table, it is not vapor. Vapor will not go out, only heat will go out. Heat will go out. This is not vapor. Vapor ಅಂದ್ರೆ ನೀವು ಟೀ ಕಡಿಮೆ ಆಗ್ಬೇಕಲ್ಲ, ಕುಡಿತಾ ಕುಡಿತಾ ಏನಾದ್ರು ಟೀ ಅವ್ನು ಫುಲ್ ಕಪ್ ಕೊಟ್ರೆ ನೀವು ಅಲ್ಲಿಂದ ತಗೊಂಡ್ಬರೋಷ್ಟರಲ್ಲಿ 50% ಆಗ್ತಾ ಇದೆಯಾ? ಆ ಥರ ಇಲ್ವಲ್ಲ. So depends on you. You have to write the answers clearly. If they ask in such cases, we are considering that vapor is going outside from the tea, so it is a open system. If vapor is not considered as a part of your research work or part of your example, only exchange of heat. When it is only exchange of heat, it is a closed system. Okay. If you are considering water vapor or steam vapor, if you are going out, then it is considered as open system. Understood? Understood. Okay. Last, compressor.
Yes.
Compressor. Compressor, why it is used?
To compress the air, sir.
To compress the air. For example, this is a compressor. To compress the air. So air must go inside. Correct. When air get enters inside the compressor, then only you can compress, no? Otherwise, it is not possible, no? So mass is going in. And mass is not coming out until unless you use this high pressure air to fill the air inside the bicycle, bike or car wheel, etc. Okay. So mass is going in. So when there is a mass exchange, then it is called open system. My dear students, Xerox machine, printer is a open or closed system?
Sir, printer, sir.
Printer is a
No, open system, sir.
open system. And dear students, first whenever any example is we give, you have to understand what is this working. So do not printer, maybe it is not working condition, light illa, printer ಕೊಡಕ್ಕಾಗಲ್ಲ. Don't think over smart ಆಗಿ printer paper ಇಲ್ಲ ಆ ತರ ಎಲ್ಲ ಅನ್ಕೋಬಾರ್ದು. Printer is used for making some copies. Okay. So why it is open system, my dear students? Where is the exchange of energy? Where is the exchange of mass? Assume this is printer. Could you elaborate your answer, please? How it is a open system? Why not it is
Sir, the copy will be kept on the scanner.
copy? Very good.
Will be
Okay.
kept on the scanner, and the output will be given as a Xerox for us.
Yes. Output. There is a question of mass. What is mass? Mass is nothing but
Means
paper. The
paper,
empty
sir.
paper. Empty paper will go inside the printer, and
The
yes,
printed one will come out.
printed paper will come out. Correct.
Sir.
Printed paper will come out, and empty paper will go inside. So when there is a exchange of mass, obviously it is open system. So what is a kind of energy interaction here? What kind of energy interaction? Could you tell me? What kind of energy interaction? To run the printer, what is the input energy required, my dear students? What is
Electrical energy to
electrical energy is
work
required.
done.
We are supplying electrical energy, current, electrical energy we are supplying, power we are supplying. So where is the question of energy? Mechanical energy, because in some parts of the printer it will be moving, no? Some wheels will be there, some paper will be there, some layer will be there. When you switch on the printer, you will get some noise, means some mechanical components are there inside. That will convert mechanical energy. Understood? So electrical energy is converted into mechanical. So it is a open system. Dear students, fan is open.
Sir, electrical, it is open sector.
Open system. Energy is also there. Mass will be there. Okay, my dear student. Now you tell me refrigerator. That is AC. AC or refrigerator. Last example. Refrigerator. Fridge ಅಂತಿರಲ್ಲ.
Yes, sir.
Or air
Open
conditioner. Open or close?
Open
Sir.
Why it is open?
Sir, because the electric
because it absorbs.
Okay. So refrigerator, fridge or air conditioning, or you can say radiator of a car. Car radiator. So car radiator, air conditioning, fridge, what you call refrigerator, whether it is a open, closed or isolated system.
Sir, it is an open system, sir.
Please justify your answer. Okay, one student is saying open system. Is any other
because
answer?
The refrigeration is the process like it's
refrigerator means the fridge. Where is the question of mass exchange? Fridge will be always closed. Okay.
Allah, sir, electrical energy.
Okay, electrical energy is going in. That is fine. Energy
yes,
exchange. Where is the question of mass?
Sir, ಅದು electrical cold energy convert ಮಾಡುತ್ತೆ.
Okay, energy exchange. You are using the word energy. Correct. Very good. Energy exchange you can see. But where is the question of mass? Where you are saying exchange of mass? Mass is going in. Mass should come out.
The air is cooled down now, sir.
Air is cooled, but which is within the system. Sir, where it is coming out?
Freezer ಅಲ್ಲಿ ಏನಾದರೂ ಅಕಸ್ಮಾತ್ ವಾಟರ್ ಇಕ್ಕಿದ್ರೆ ಅದು ಮೀನ್ಸ್ ಅದು ವೇಪರ್ ಆಗಿ
ಒಳಗಡೆ ಇರುತ್ತಲ್ಲ ಹೊರಗಡೆ ಎಲ್ಲ ಬರುತ್ತೆ. ಈ ಫ್ಯಾನ್ ತರ ಹೊರಗಡೆ ಬರುತ್ತಾ ಆಟೋಮೆಟಿಕ್ ಆಗಿ?
ಇಲ್ಲ ಸರ್, ಅದು ಓಪನ್ ಆದಾಗ ಒಂಥರ ವೇಪರ್ ತರ
ಓಪನ್ ಆದಾಗ ನಾನು ಓಪನ್ ಮಾಡಿಲ್ಲ ಅಲ್ಲಿ. ರೆಫ್ರಿಜರೇಟರ್ ವಿಲ್ ಬಿ ಆಲ್ವೇಸ್. ಎಸಿ ಏನ್ ಮಾಡ್ತೀರಾ ನೀವು? ಓಪನ್ ಮಾಡ್ತಾ ಕೂತಿರ್ತೀರಾ. ವೆನ್ ಎವರ್ ಎಸಿ ಡೋರ್ ಓಪನ್ ಮಾಡಿದ್ರೆ ವಾಟ್ ವಿಲ್ ಸೇ ಯೂಶುವಲಿ, ಪ್ಲೀಸ್ ಕ್ಲೋಸ್ ದ ಡೋರ್. ಕರೆಕ್ಟ್ ಆರ್ ನಾಟ್? ಹಂಗಂದ್ರೆ ಇಲ್ಲಿ ನಾನು ಈ ಪ್ರಿಂಟರ್ ಕ್ಲೋಸ್ ಮಾಡ್ಬಿಟ್ರೆ ಪೇಪರ್ ಬರ್ಲಾರ್ದಾಗ ಮಾಡ್ತೀನಿ. ಹೊರಗಡೆ ಬರಬಾರ್ದು ಪೇಪರ್ ಅಂತೀನಿ, ಒಳಗಡೆ ಹೋಗಬಾರ್ದು ಅಂತೀನಿ. ದಟ್ ಈಸ್ ನಾಟ್. ಫಸ್ಟ್ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ವೆದರ್ what is the use of this device. First, AC is for reducing the temperature. So we are supplying electrical energy. So this electrical energy is going in and one form of energy is coming. So when you speak about air conditioning, fridge and refrigerator, which is a working fluid? The refrigerant. For example, you have a four-wheeler car, AC car. So for every 5 years or 6 years, you will be filling the refrigerator. AC at whether the refrigerant is coming out, the working fluid will come out? No. Working fluid, the refrigerant will not come out. So it is a closed. If the refrigerant working fluid is coming out outside the system, then you can say it is a open system. Radiator of the car andre, are you supplying water continuously? For continuously we are supplying water in the radiator for cooling.
Yes, sir.
Have got my point? For initially you will add
Yes,
some
sir.
amount of water and you will leave it. Okay. After 4 days, after 5 days, again you will fill the water in the radiator. Correct or not? For example,
Yes, sir.
lubrication
Mm.
oil. Only when you give for service,
Mm.
you will add some lubrication oil in the engine. Correct or not?
Yes, sir.
Okay. Are you adding lubrication oil continuously to the engine every day, every moment?
No, 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 no.
No, no, no.
No,
Correct or
sir.
not? So when you give
Yes, sir.
service, then only they will add the lubrication oil. That lubrication oil will be continuously circulated outside the engine and it will be remain same position. Okay, working fluid is not coming out, no?
Mm.
Lubrication will not come out.
No, sir.
Refrigerant will not come out. AC, air, every day are you filling the air condition AC? Every day are you filling the refrigerant inside the AC? Freon, atara.
No.
Manilalla every day AC
No,
change
no.
ಮಾಡ್ತಾ ಇದೀರಾ? AC pipe every day change ಮಾಡ್ತೀರಾ?
ಇಲ್ಲ, sir.
Okay, once in a
ಇಲ್ಲ.
maybe two or twice in a year, or maybe for every 3 years
No.
once, like that. Okay, so refrigerator, fridge, AC, radiator or closed system. Okay, sir, ನಾನು ಆಪಲ್ ಇಡ್ತಾ ಇದ್ದೀನಿ. Apple is not a working fluid, my dear students. Apple, it is used for your purpose. Refrigerant is a working fluid there. For example, in the steam turbine, steam is a working fluid. Here, tea is a working fluid. Understood? Tea is not coming out. If you are considering vapor tea, then you can say it is a open system. Here in the turbine, steam is going in. So steam is working fluid. Steam is coming out. So it is a open system. So illige ನಿಲ್ಲಿಸ್ಬಿಡೋಣ. So we'll stop here. So please again you browse some examples. Compressor,
Okay.
turbine, radiator. I will give some examples. You identify whether it is a open, closed and isolated systems. So what is assignment is? Assignment is define. Assignment questions you write. Assignment. It will be asked for 10 marks. Assignment, define system and explain different types of thermodynamic system. Different types of thermodynamic system with examples. With examples. Okay. Do you have any doubts?
Sir. Sir.
Yeah.
Sir, ಅದೇ ಓಪನ್ ಸೈಕಲ್ ಒಂದು ಸ್ವಲ್ಪ ಡೆಫಿನೇಷನ್ ಹೇಳಿ ಸರ್.
Open system, it is a thermodynamic system where you can see exchange of both mass and energy.
Okay.
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 You can write some example. Pump, for example, the pump what you are using in your home for lifting water from sump to the tank, whether it is open system or closed system. Pump.
ಆಗಲಿಲ್ಲ.
Pump, what you are using
Okay.
for pumping water from sump to the tank, overhead tank.
Yes, sir.
So whether it
It
is
is a open system, sir.
open system. Why it is open
Open
device?
system.
Pump is, you said, open.
Because it is mass.
Mass is
Yes,
which
sir.
is the
Pumping
mass
of the
in the
fluid.
pump?
Water.
Water. So where is the question of energy? Energy means which one?
Energy
means
is
what?
electrical energy.
Yes, we are giving electrical energy.
Electrical energy.
This electrical energy is converted into pressure energy. So easily the
I
water
can,
is
yeah.
going upward in the upward direction against the gravity, and you can store in the in the tank. Okay,
Okay.
this is a question you write in the notes. Okay, so thank you.
Okay, sir.